Hey, what's going on, Heritage? It's Mr. Leong again, and we're going to look at some notes today on transforming quadratic functions that are in vertex form. Right, so right on the top of your notes here, we've got kind of the generic structure of vertex form. There's a coefficient, a multiplier. There is a number that's being subtracted from our variable x. Okay, all that's being squared. And then there's some constant that's being added. So what I want to first do is go to Desmos and take a look at some things here, right? So if you look on my screen, I've got, just a second degree x term, right, x squared. And I have a table of values. So 0 squared is 0, 1 squared is 1, 2 squared is 4. Right, we can see those familiar points there. But what I want to do is I want to make this function look like that vertex form without changing the way the graph looks. So here's how I'm going to do that. So here maybe I should first write what the vertex form is. Okay, so it was f of x equals a times x minus h raised to the second power plus k. Okay. All right. So let me first just put a set of parentheses around x. Okay. You notice that hasn't changed the parabola, hasn't changed my table of values. Okay. Let's subtract. Now, what could we subtract? What number could we subtract that won't change the results? Well, subtracting 0 doesn't change the result. Okay. What could I multiply by that won't change the result? So think of your favorite number. Maybe it's 7. Right. What could you multiply 7 by where the result is still 7? Well, yeah, multiplying by 1 doesn't change the result, so I'll put a coefficient of 1 there. And then what could I add that won't change the final result? Okay, well, adding 0 doesn't change the result of anything either. So now I've taken my function, which was just x squared, and I've kind of written it in this vertex form, right? So 1 is this a coefficient, it's a multiplier. 0 is this h number, and then I have another 0 for the k number. So what I want to do next is kind of explore how changing each of these numbers changes the graph. Okay, I'm going to start with k. So right now it's plus 0, but what if we make it a plus 1? Well, you can see that my parabola, all the points just shifted up one space. And if you look at my table of values, the second column, all those values increased by 1. If I make it a plus 2, you see the points have shifted up even more. Plus 3, plus 4, plus 5. Right. So that k value, what it's doing is it's called a vertical shift, right? It's going to make the entire parabola shift up. We can also make it shift down, right? So let me reset it back to 0. If I make the k value -1, right, all the points shift down one space. Make it -2, they shift down 2 spaces. 3, -4, and -5. So using Desmos, we now have a very clear idea of what this k value represents, or how this k value affects the graph of our quadratic function. It shifts it up or it shifts it down, depending on whether you're adding or subtracting. All right, so let's go to our notes and record that down. Sorry, it just takes a minute for me to switch from the computer to the document camera. Okay, so we were talking about the k portion of the vertex form, and we saw that if k was greater than 1, so if I was adding some, sorry, greater than 0, my fault. If k was a positive number, if we were adding something, that caused the parabola to shift up. So this causes a shift up. Okay. If k was a negative value, so if k was less than 0, that would cause the parabola to shift down. Okay, and that kind of makes intuitive sense. We think positive values increase things, and increasing goes up. Negative values decrease things. Decreasing means it comes down. All right, let's go back to Desmos. And I next want to explore the H portion of the vertex form, right? So that's this 0 inside the parentheses. Okay. So let's change that 0 to a 1. You can see that the parabola just shifted to the right 1 space. Okay. Make it a 2 and it shifts 2 spaces. Make it a 3, a 4, and a 5, and it just keeps shifting more and more to the right. So this H value, what it's doing is it's causing the parabola to shift in a horizontal direction. Let's go back to 0, and that kind of resets the vertex back at the origin. Okay. And then let's try subtracting negative numbers. Okay, so if we write x minus -1, okay, now the parabola is shifting to the left. -2 goes even more. 3, -4, -5. Okay, so again, that kind of makes intuitive sense. Negative values would be going to the left, and positive values would be going to the right. All right, I'm going to reset it back to 0, and everything's centered there at the origin. Okay. So now I would like to go back to the notes and record that. Okay, so we were looking at the H value there, right? That was the number inside the parentheses. Okay. All right. So this H value, right? If H was a positive number, okay, that shifted the parabola to the right. Okay, so it causes a shift to the right. Okay. And if that H value was a negative number, okay, that made it shift to the left. Causes a shift to the left. Okay. All right. So H and K basically just move or shift the parabola around. We can move it up, we can move it down, we can move it left, we can move it right. But the parabola in those situations maintains its original shape, right? It doesn't get wider or narrower or anything like that. It just has the same shape. Okay, so the last thing that we need to do is we need to look at this A value and how the A value affects the parabola. Okay, so let's go back to Desmos. All right, so we have our parent function, right? This is just y equals x squared. We have our 0, 0. The next 2 points have y coordinates of 1 and then y coordinates of 4. So let's mess around with this A value now. Okay, so right now A is 1. We know multiplying by 1 doesn't change the result. But let's make it a 2, or a 3, or a 4, or a 5. Okay? And so what's happening is the vertex is staying locked in place, right? It's staying at the origin. And what's happening is the other points are stretching away, right? These 2 points, instead of being the usual 1 space away from the origin, okay, I can stretch them to be 2 spaces away from the vertex, or 3 spaces, or 4 spaces, or 5 spaces. So whatever this A value is determines the distance, how far apart, how far away these 2 points are from the vertex. All right, cool. So we can stretch those points vertically away from the vertex. What if we reset it to 1? Let's try numbers less than 1, like fractional values. So what if we had like 1/2? Okay, now you can see that these 2 points here and here are only half a space away from the vertex, right? So they've gotten closer. If I were to make that a 1/3, they're even closer. 1/4, 1/5, 1/6, 1/7, right? 1/100th, right? Just brings those points closer to the vertex. Okay? So in this case, the points, their distance is shrinking. They're getting closer to the vertex as opposed to stretching away from the vertex. Okay. All right, so a quick recap. If the a value is larger than 1, such as 2 or 3 or 4, the points stretch away from the vertex. If that a value is less than 1, so positive, like a half, a third, a fourth, a fifth, then the points shrink closer to the vertex. Okay. What if that a value was negative? Right? You can probably guess what's about to happen, but let's just watch it play out. If we have -1, right, everything just flips down, right? So instead of the parabola opening up, which we call concave up, it opens down or concave down instead. And so the negative sign just determines the direction the parabola opens. We can still stretch or shrink the points, right? So if I make it -2, it opens down, and I'm stretching those points away from the vertex by a factor of 2, or maybe 3 or 4. And I can still reflect the graph and shrink the points closer to the vertex just by using fractions like 1/2. So it's reflected, but the points shrink back to the vertex, 1/3, 1/4, 1/5, etc. Okay. All right, so now I want to just record that. Just waiting for the camera to focus. Okay. All right, so if that a value is bigger than 1, okay, that causes the points to vertically stretch away from the vertex. So we just call it a vertical stretch. Okay. If a was less than 1, but still bigger than 0, so now we're thinking about fractional values like a half, a third, a fourth, right? That causes the points to shrink closer to the vertex. So we call that a vertical shrink. And if a were negative, so if a is less than 0, right, that causes the parabola to open down instead of open up. Okay, so we say that's a reflection across the x-axis. Reflection across x-axis. You can also describe it as just being concave down. Okay, the parabola just flips upside down. Okay. Now, one really important thing to remember when you're dealing with vertex form is signs. Okay, it's very important that we have a minus sign inside the parentheses and a plus sign with the constant. Okay. So you're going to want to make sure that, as you're looking at functions or you're writing your own functions, that you try to keep the signs where they are. Okay, minus sign here, plus sign there. Okay. All right, so let's look at the directions. Use the features of the vertex form, quadratic equation, to describe the transformations that occur from the parent function f of x. Right? So that was the one that I had started with in Desmos, x squared. And so that has, if you were just to write 0, 1, 2, -1, -2, and you square all these, those would be 4, those would be 1, and that would be 0. So you'd have 0, 0, 1, 1, -1, 1, and then 2, 4, -2, 4, right? Just kind of those very traditional points. All right. So problem number 1, we're going to take a look here and just look at the signs first of all, right? We've got a minus sign in the parentheses, which matches with what we have here, and then a plus sign with the constant, which again matches here. So I'm liking the signs right now. Okay. Now I've got a number after the minus sign, and I've got a number after the plus sign, so that's going to be my h and k. Right? We can just record it here. H is 1, k is 2. And then the a value, remember, we look for that in the very front, in front of the parentheses. Okay. And if there's no number there, then you can assume that it's a 1, right? Multiplying by 1 just doesn't change the result. Okay. So a is 1. All right. So we know that's not really going to do anything But what is the h value going to do? Well, because it's positive 1, it's going to shift it to the right. And k is positive as well, that's going to shift it up. You can refer here, right? When h is greater than 0, we shift to the right. If k is greater than 0, it shifts up. So this is going to be a shift to the right. And this is going to be a shift up. Okay. How far to the right? 1 space to the right. How far up? 2 spaces up. Okay. All right. Number 2. Okay. We see that we have, let's use a different color, a plus sign and then a minus sign. Okay. Which is not exactly how we want to see it. Okay, we want a minus sign in the parentheses and a plus sign with a constant. Okay. So I'm going to go ahead and write this as h of x equals -2 parentheses x minus -1. Right. Adding 1 is equivalent to subtracting -1. And then I'm going to write this as plus -3. Okay, subtracting 3 and adding -3 are the exact same things. So now I've got the minus sign in the parentheses and the plus sign with the constant. All right. So the number in front of the parentheses, it's the a value, so it's -2. The number after the minus sign is our h value, so it's -1. And the number after the plus sign is our k value, that's -3. All right, so let's describe each of these things. Okay, so a is negative. It's less than 0. Okay, that means the parabola is going to open downwards. It's going to be concave down. Okay, and the fact that numerically it's a 2, right, that's going to stretch the points away from the vertex. Okay, so it's also a vertical stretch. Okay. H is -1, so if we refer to our chart, okay, when h is less than 0, we go to the left. Okay, and then k is -3. Again, refer to the chart. Oops, yeah, here. If k is less than 0, we shift down. So this is a shift down. All right, so there's a couple of you-try problems. There's 3 of them. So pause the video, go ahead and try all 3 of them, and then unpause and check your answers with me. Okay, so you try number 1. So again, we see a plus sign inside the parentheses and a minus sign with the constant. We're just going to switch that up a little bit. So we'll write this g function as x minus -3 squared plus -1. And just for kicks, I'll put a multiplier coefficient of 1 in the very front. So now this matches up with my vertex form here, right? We want a minus inside and a plus with a constant. Minus in the parentheses and a plus with a constant. All right. So a is 1, h is -3, k is -1. All right. So an a value of 1 does not affect the shape of the parabola at all. Okay. There's no stretch, there's no shrink, there's no reflection. Okay. H -3. Okay, that'll be a shift to the left. K -1, that's going to be a shift down. All right, you try number 2. Okay, so this part's good. I do want a minus sign in the parentheses, but I want to have a plus sign with the constant. So I'm going to write this function as the negative of x minus 3 squared, not going to change that, but I'll write the last part as plus -4. So we've got the minus sign and the plus sign. Now, what number would go with this negative sign? If you said -1, you'd be correct. So that's our A value. 3 is our H value, and -4 is our K value. So the fact that A is negative means that the parabola is going to be concave down. Okay. And then the numerical portion here is 1. So multiplying by 1 doesn't stretch or shrink the points, so there's going to be none of that. Okay. H value is +3, so that'll be a shift to the right. K value is -4. That's going to be a shift down. All right, third and final one. Let's see. So we have plus in the parentheses and a minus with the constant. So we're going to first rewrite it so it's minus and then plus. So g of x equals 1/2 x minus -5 squared plus -1. Got that minus and that plus. All right, so our A value, look to the very front of the expression, it's 1/2. The H value, look after the minus sign, it's -5. K value, look after the plus sign, that's -1. So the A value is less than 1, it's 1/2, so that's going to cause the points to shrink and get closer to the vertex. Vertical shrink. H value is negative, so that's going to be a shift to the left. And the K value is negative, that's going to be a shift down. So, if you got all those problems correct, congratulations. If not, what I would do is probably just play around in Desmos, explore a little bit more. And, if you do it enough, right, you kind of will get a sense of how these values and affect the graph and the role that they play. Let me just do one last thing before I end this video, right? Is we can add sliders here. Right? So I can actually just call that coefficient A, call that coefficient H, call that coefficient K, and then we'll add sliders. So let's set the H value to 0 though, and the K value to 0. So that's our traditional parabola, right? Vertex is at the origin. Now, the A value, right, as it gets bigger, the points stretch away from the vertex. As it gets smaller, the points shrink back towards the vertex. And then once we have a negative value, then they flip over, right? It opens downwards. Stretch those points away or shrink them back towards the vertex. Okay. The H value, right? You can cause the graph to shift left or right. Okay, that looks pretty cool. Yep. And then the K value is going to cause the points to shift up or down. Okay, and it all depends on whether K is positive or negative. So Desmos is free. So again, just go to desmos.com, type in the function, play around with it, and then you'll just kind of get a better sense of how all this stuff relates. All right, cool. Thanks for watching.